for this is for Monday, the 19th of October, and go right to the screenshots here in a second. A couple of announcements. Remember, the test is not tomorrow now. It's not Tuesday. It's going to be Thursday, and also your packets due Thursday. So for virtual kids, there's three options on packets on taking the test on Thursday. And we talked about these in the previous wrap-up video, but you can come into my class anytime on Thursday, anytime. Well, you don't want to come in when the students are there. I'm trying to avoid that. So I don't go to lunch till about close to 1. So I'll be back in the room by 2. So I'll be in the room from just Thursday. We got faculty meeting. Shoot, forgot about that. All right, that's fine. I'll be in the room from 2 to 4:15. Okay. And then I've got to go eat dinner. Then I got to come back to the room. But you know what? I don't see any reason why you couldn't come up Thursday night, because I had to be there in my room from 5:30 to 5, I think, to 8. Let's say 5:30 to 8 anyway. So you might as well be somewhere around there taking the test. Now, once you start the test for virtual kids, I'll give you an hour like I would regular students to take it. So anytime. Now, Thursday, the only time you couldn't come in Thursday, you'd probably be in the morning, and then at lunch I'll be gone. So from 2 p.m., and then I'll be gone from a little bit. I'll be gone from about 4:15 till about 5. And I'll be back from 5 to 8 Thursday night. So that's in the room or in the, at the picnic table or something, or in your car, I guess. I mean, we can work something out, but try and come up paper and pencil test. And that's the easiest way to do it. The other way is Thursday, like at now, because I'm up there till 8 because of parents' conferences, Thursday at like 8:30 to 9:30. We'll just say 9 to 10. Late night Zooming 9 to 10. And I'd probably open up the Zoom about 8:50 and then give you 10 minutes to get started, get you ready to go. Thing is, you have to have the paper. So you would have had to come by the class, and you just come by, and if you'll come by and text me 405-760-8425, then I'll bring it out to your car so you have the paper if you wanted to go home and do it. But while you're doing it, you got to show me the blank, show me the test, and then you know that nothing's done on it, and then start working. This is a huge effort to try and make the test fair to everybody. It's not fair to in-class kids if virtual kids get all night to do it. If I put it electronically, I don't mind my take-home test getting out there in the Ethernet, but I don't like my in-class tests, which I try and keep somewhat protected, getting out there. I guess the other option is never give an in-class test, which means that there's no hammer. At no point in the year is there any kind of hammer. And kids will start to just fade away. They go, well, now you can do that kind of stuff for AP physics, because those kids all those kids have already proven a year's worth of physics, and they want to be there, and there's no reason to take into this. You want to be. So what I'm saying is, we got to make this work. And the hardest students will be those that will not step foot in this building under any circumstances, even when no one's there. No students are there. And then we could do the in your car, I guess, or we could do at the picnic tables in the afternoon. I don't know what the weather's like on Thursday. Anyway, we'll try and get through this one way or another. Thank goodness it only happens a couple of times this semester. All right, so I'm going to share the screen now. And we'll talk about what happened today, Monday. So this is Monday, October 19th, class number 5 for packet 2. So the announcements here, we remember that the packet is due. You have to have a yellow, well, it could be any kind of color. You can just print this off, but this has to be there on the cover for your packet. Now, for virtual kids, if they come to school or come to the picnic tables or into the car, once I give you the test, the paper copy of the test, you give me your packet. Okay. I don't like to leave the test sitting on my porch because, you know, there is such a thing as test security. So I've got to somehow witness you taking the test and then you giving me your packet. All right. Somehow, okay, unless you have some kind of a sickness or some kind of a immune, which people do, I just need to know that. If you have a very compromised immune system, and you cannot even be outside, then let me know, and then we're gonna have to work something out with you, okay? And I dig it, but I just need to know. So anyway, you put this cover sheet on there. Make sure you fill in these, you check off these boxes, okay? Now don't check them off unless it's correct. So you can read up here as to what each column tells you. And then there's how many points each one's worth. So you can see that's the notes are 34 points, but that 1.8 is worth 30 points. So make sure that's done. And on that one, it's crazy. It's worth 30 points. We didn't even do number 4 on that one. You will get this. You will get a paper copy of this for your test. Okay. It'll be in a page protector, and everybody gets a paper copy of the equation sheets. Now, for this test, there's only one. It'll be like 4 sides by test 2. It'll be 8 sides by test 3. You know what I'm saying? It gets up to like 24 sides by the time we're done. This is still homework. This is 2.1, 4 and 5. Get 4 and 5 taken care of. I'm going to change the due date to, remember to do this, to Sunday, not Thursday night, because Thursday's a test and it's too crazy. So Sunday night, we move this thing back to, I'm going to move it back to Sunday at 11:59. Okay, this coming Sunday. Now we still have problems 6 and 7 to do. I think all of these problems, this is all, it's not, although it's not on the test per se, this is packet 2, but the first sheet of a packet, a lot of times is kind of a review of the previous packet. So this is a pretty good review sheet for packet 1. So it's a pretty good sheet to look at for the test. Remember to keep your packet notes. So you'd say packet 1, packet 2, but you got to keep track of your discussion points, Zoom points, Facebook points. Okay, so last time we went over this on the last wrap-up video. This was from Friday. We did the front of sheet 2.2. And we talked about this in the last wrap-up video, so I'm not going to go over it that much. But we realized that it is wrong to say, if we're taking the average velocity, and these are the velocities here, if we're taking the average velocity, it's not just these 5 added up and divided by 5. That's called a mean, M-E-A-N, and that doesn't work for weighted averages. It's a weighted average because we spent more time as the old man, that's phase 1, and as the funky chicken than we did as the runner. Okay, so it weights it way too much towards the runner, or unfairly so. So to get a weighted average, you have to look at, well, what percent? The total time was 36 seconds. Of 9 of those seconds, I was the old man. So 9 divided by 36, so it's really that percent. But that takes forever. A faster way to do it is just to connect the first and last point, find the slope of that line between them, and that's the overall average. And we found that the overall average here was negative 0.11 meters per second. Now the back, we did this together last time on the last wrap-up video. We did it in class on Friday. But then we went ahead, and then today, getting into a little bit of stuff we talked about today, we talked about this on the wrap-up video, but we didn't talk about it in class. So we did talk about today in class though. So this part, this red, I want you to go ahead using a colored pencil. So we finally broke out the colored pencils in class. The kids are going to pull, and I took those at the end of the day. I took those colored pencils and I put them under UV light for 15 minutes. So that supposedly is enough to kill anything off. And then I'll pull them out tomorrow. We've cleaned. Well, the ones in the junk box are all clean. They're all from March. So we'll just keep adding. We'll just keep cleaning them up every day at the end of the day. All right. So we're using colored pencils. So you need on your packet 2 is going to be much more colorful than packet 1. But I need to see these colored in. We talked about this last time. This is the reason why it's so important. This is the beginning of calculus. So the area, calculus involves 2 things. First semester calculus, if you're in AB, first semester calculus is all derivatives and power rule, which we'll get to later. Second semester calculus is all areas and integrals. So this would be taught in second semester calculus, and it's the area under these curves. Now, if you think about this, this is meters per second, the height, the base is seconds. So meters per second times seconds gives me meters. So the red, this is the old man, this is the aerobics, this is the marching band. When I add these up, the question I asked the morning classes, when I add up the red areas, what do I get? And finally somebody says, well, that'd be 15 meters because I went 15 meters. This should add up to, let's put it in black here. This one should add up, I went from 0 to 3. So this one should add up to 3 meters. Let me wide out some space here so I can put these in there. This is not a unimportant concept. This is a huge concept. I don't waste time on unimportant concepts. Everything we talk about in this class, you will apply over and over again to other classes. So this is 3 meters, okay? This was the aerobics that went from 3 to 10. So this has an area of 7 meters. And this was the marching band 10 to 15 has an area of 5 meters. This was the run, and I ran from the 15 meter mark to the 3 meter mark. So this has an area of negative 12 meters. And that's right. You can have, this is a calculus concept. You can have negative areas. The blue here represents negative areas. And then the funky chicken, that was from 3 to negative 4. So this has an area of negative 7. I'll probably go over this again tomorrow in class because we went over it decently in third hour, but kind of breezed through it in first and second hour. All right. Sometimes the more I go over something, the more important I realize it is. So anyway, everything's important, but it's just what do you have time to emphasize? So I add these up here and I get 3 plus 7 plus 5, that's 15. So the red area is 15 meters. And you can prove it to yourself by multiplying base times height. And then the negative area is negative 19 meters. And so when I add these up, I end up overall going negative 4 meters. Kind of cool, eh? But that is what you call integration calculus. And there's all kinds of symbols associated with it. We'll get to that. That might even be second semester before we talk about that. Now, a lot of high school classes don't even mention calculus, but I think it's important that I know you're not supposed to be, you don't have to have calculus. And I'm only gonna show you graphical calculus mostly. I'll show you some formulas, and we'll talk about some concepts. But if you don't understand calculus, you'll never get through a semester of physics in college. I mean, real physics. You can take physics for poets or physics for doctors, which is kind of a joke physics, which is okay. I mean, there's nothing wrong with it. It's good. But real physics is calculus based. And so if you want to do engineering, if you want to actually do a science, you have to take real physics in college. And that's what I'm trying to teach you. I'm trying to prepare you for that. Okay. We did Joke Monday. And the Joke Monday I had queued up, the district deemed it inappropriate and they blocked it. So I'm going to have to talk to the district about that because it wasn't bad. And then so I showed my second choice, which was okay. It was kind of funny. But we will do Joke Mondays now every Monday or Tuesday, whatever is the first day of the week. All right, so today's physics we talked about. Oh, hello, whoops, don't look at that. Daggone it. Let me pause this. Wish I could rewind. Can you rewind? Okay, I'm back. Sorry about that. I accidentally showed you I'm trying not to do that. I mean, if I did wrap-up videos and all I did was show you the finished products, and this is why, daggone it, you know what? I need to put the wrap-up video above the screenshots so that, or in a different place, maybe. Yeah, good point. All right, because right now I'm putting the wrap-up video and the screenshots in the same place on Canvas. So in order to get to the wrap-up, these are for virtual kids. In order to get to the wrap-up video, you have to scroll through the screenshots, which means I give away all the stuff and then you watch the video. That seems backwards. So I'm thinking now I'm going to do a reformat and I'm going to move all the wrap-up videos to another spot in the same module. All right, so anyway, note to self. So when I was making the test up this weekend, I noticed that this was question 10 of last year's test, and it's worth 18 points, and it's worth quite a bit. And this was a derivation. And so I realized, whoops, we didn't do that derivation with all the crazy alternate schedule and stuff. Somehow I got lost in the shuffle. We've talked about this. This is the equation we're trying to derive. And we have actually worked all around it. Hold on a minute. Let me get it to call up here. Yeah, so we've worked, this is the equation we're trying to derive. And we've worked all around it, but we haven't actually derived it. And derivation, and here's what we're given. If we're given this information, derivations are being able to derive a formula from another formula. In other words, manipulate the symbols, bring in definitions of other things through symbols, substitute, rearrange. All that is a very necessary skill, especially if you're going to go into what's called theoretical physics. So physics is broken up into theoretical physics and empirical physics. So the theoretical physicist does most of the thinking. They think for a living, and they, not that the empirical doesn't, but they basically are given a very nice laptop and a good scratch pad, and they're supposed to come up with formulas and ways to see the world. Like Stephen Hawking, you know, Albert Einstein was a theoretical physicist. Albert Einstein was notoriously dangerous in the lab. He was a little bit clumsy. So empirical physicists, they work with, you know, $1 million or $1 billion machines like large hadron colliders or electron microscopes, whatever they're working with, and they are performing experiments. Which is awesome. Maybe you like that kind of stuff. They're using Arduinos, well, more than Arduinos. They're using these sophisticated circuit boards and all this, and they're, you know, so they're doing experiments with all kinds of cool instruments. So if that's your thing, I probably lean towards the theoretical. It's just my preference. I'd rather just sit and think about it and try and think about connections rather than, because guaranteed, man, you start buying equipment and it starts breaking down, and then you got tolerances and you got sig fig issues, and you know, so I dabble in both, in explaining both, but I lean towards theoretical. So this is a theoretical approach to coming up with this formula right here. It's a very important bridge equation between linear world and circular world. Okay, so here we go. This is going to take us about 5 steps. Now, somebody pointed out once, I said, well, Mr. Askey, this is cool, but I don't think Isaac Newton knew what the formula was he was going for. I mean, Einstein wasn't already given E is equal to mc squared, but that's true. Right now, I'm trying to train you on a technique, and then you're going to go out there, and in maybe 10 years, you're going to come up with a symbol relationship that changes the whole world. But this is like training on how to do it. All right. So we start off with this information here, and this is this information here, and this is just given. It's by definition what a radian is. It's the arc length for a pizza slice. It's the arc length over the radius. When I put those two over each other, I'm going to have meters over meters or feet over feet or inches over inches, and they'll have no units. But that's just by definition. So I introduce it. I introduce it here saying it's by definition. Okay. So I'm trying to work. I know what I'm working for. That's the advantage I have over Einstein. He didn't know he was working towards E is equal to mc squared, but I'm working my way towards it. I mean, can you imagine developing a new equation, and you're the one they call it the if I come up with one, they would call it the ASCII. I mean, that'd be the ASCII equation. We have in physics, we have the Schloop shortcut, we have the Villatoro shortcut, we have the Constantine shortcut. We have shortcuts, but no student of mine in 35 years has ever developed. They develop shortcuts to get problems easier, but I cannot think of any student that has developed their own equation. Maybe that's asking a little too much, but it's something to play with. This is like a puzzle. Okay, so here's our puzzle. We got to introduce puzzle pieces, but somehow we got to get from here to here. So here's a little pro tip. You know you're trying to end up with delta S isolated, right? So I'm going to go ahead and isolate delta S. That's my first step. Okay. So I multiply both sides by R, and I have R delta theta equals delta S. Okay. Easy enough. And that's just, I realize, yeah, well, we just call that rearrange. So we put a rearrange here, RE. The next step then, let's go ahead and do another. This seems trivial, but I'll rearrange it again so it looks just like it looks on the answer. And so this one would just be to move it around. If A equals B, then B equals A. Delta S equals R delta theta. You had a preview of this when you did geometry. You do two-column proofs. I know when I was in high school, we spent an entire 9 weeks doing pretty much nothing but two-column proofs. And people didn't like it. I know you guys don't necessarily like it, but I kind of started to like it a lot because it forces you to be logical. It forces you, it makes you a good lawyer. Because it's logic and it's the next step, and you can't introduce anything unless it's proven true. Okay, so here we go. The next step then, I want to end, remember I have it, but I want a W. I want an omega in my answer. So I go back and look at my repertoire, which is not a whole lot of equations to choose from. So I go back and look at, well, the one I see is, by definition, omega equals delta theta over time. It's simply the velocity of how fast something's going round and around and around in circles, revolutions per minute. We talk about it as radians per second, but it's the same thing as RPM in your car. All right, so that's omega, and that's just intro. Okay, some mathematicians might say given, but we say intro because you're introducing it into your argument. And let's see. Well, what's the next move? I see that I also brought in, this is a great move here, because I brought in an omega and a t, which is just what I need down here. I need an omega and I need a t. But let's get this so it's more palatable. I see a substitution coming up. Now, there's a combination of these moves. Intro, iso, sub. Those three go together all the time. Intro, iso, sub. So I'm going to next isolate the delta theta. You'll see what I'm doing. You'll see why in a minute. So delta theta, so multiply both sides by t. So delta theta then is omega times t. And that's simply isolate. I isolated the delta theta. So now look what I can do. I can now take that and dun, 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 I can sub this in for that. You see where they're the same thing? If A equals B and B equals C, then A equals C, law of transitivity property. So let's just do, now the next step is to sub. Oops. That, I think I have a solid help video on this. I'll look for that, put it on the Facebook group. Substitute. So now I have delta S equals R omega T. Well, I just got to do a little quick rearranging and I have the way I want it. Dun, dun, dun. Did it. We just did our first derivation. Now, it will not be on the test on Thursday, but there will definitely be a derivation on the test towards the end of November. Now, I don't know whether it'll be this one or whether it'll be another one coming up. We have like, this was a one, what did I call that, a step, I guess. This was a 1, 2, 3, 4, 5, 6, 7 step, to be generous, a 7-step. We have a 12-stepper coming up. So we have some that are harder and some that are easier. All right, so there you go. This is what I did in class. That was third hour, my best effort in class. Kind of like this one better. The next thing we did was we looked at 2.2. Oh, well, we finished up. Sorry, I'm going to back up for a second. We did finish up this. We did the bottom down here. We answered those questions, 7, 8, 9, and 10. Sorry to mess you up and back up a little bit. 7, 8, 9, 10. It's called a step graph. It's called a piecewise function, but a more specific name is step graph for this particular one. And it is a function. Passes the, that's what we do in those open circles. What are the slopes? They're all 0, of course. Did the velocity change? No, it didn't within the intervals, but it did change overall. And then the last one is to go ahead and draw well, look at the average, overall average velocity. And the average velocity here we found was negative 0.11. So, and it didn't, if average velocity is average, right? It doesn't change. And so we went and plotted that. I'm so sorry to go back and get this out of order a little bit, but we went back to see the green horizontal line there. That's supposed to be at negative point. Negative point. Oops, green. Negative 0.11 meters per second. That's so I do it. That's why they had to use colors today in class, because if you're going to put a function over a function, they've got to be in different colors. Otherwise, you're really going to piss off the reader. You know, what's going on? So it's really two functions, one overlaid on top of the other. Sorry about that. Now let's go to today's, what we spent the day on. What am I at now? About 27 minutes, 26. All right, so we're going to work on the front of this. We're only going to do the top half of the front. So it's not so bad. Okay, so there's nothing new about the front of this sheet. 2.3 is a lot like 2.2. It's a little bit of practice in the front. Now the back is different, but the front is kind of an extension of what we already been talking about. So this is Slappy the clown, and he is trying to get back to his trailer. He starts off at the 40 meter mark. Now people look at this and go, man, that Slappy sure is walking in a zigzaggy path. No, Slappy's walking in a straight line. His speed is changing. Notice it's X versus T. It's not X versus Z, right? Or X versus Y. It's just one dimension through time. So it's like Slappy's on railroad tracks, all right? Or he's in a hallway or something. Anyway, so he walks down that hall, or say he walks towards his trailer. His trailer's at the origin. Okay, we'll mark that as trailer. Trailer's right here. Where he's trying to get to. his goal is to get back to the trailer. So he starts 40 meters away. He walks, and that's what we'll see later. That's a slow walk. And then he takes off running a pretty fast run, and he runs right past his trailer somehow, like he's a sidewalk. He runs right past it. Then what's he doing here from 40 to 60 seconds? You got it. He's just standing there. Someone in third hour said, well, he must have fallen down. So he's just sitting there not doing anything for 20 seconds. Then he turns around, realizes his mistake, and he runs like a bolt of lightning. Not quite as fast as Usain Bolt, but pretty daggone fast, as you'll see in a second. Up, and then once again, overshoots his trailer. He turns on a dime, which is impossible. This is the more we get through physics, the more possible the scenarios. But this is called a diffraction point. I didn't tell the kids this today, but diffraction points they're impossible. You can't, in nature, you can't have diffraction points like this. In reality, there has to be a slowdown period, a speed up period. But we're getting there. We're getting there. So he turns on a dime and then goes back, misses it again, finally turns around and gets back up to the trailer. Okay, so we have to diagnose his motion. So first thing I want to do is turn everything into right triangles. Now here's where you need two colors as well. We're going to do one color for the negative right triangles and one color for the positive right triangles. So I'll start off and then I'll pause it and show you the finished product. But here's what you do. So you turn this, get your pencils out, maybe it's red, whatever color, and you're turning all these into right triangles. Vectors, these aren't vectors, these are line segments. But vectors and line segments at angles are really the hypotenuse of a right triangle. So all my negative velocities, I'm going to make red. I'm going to make those red upside down triangles. Okay. And I guess we'll just get to do it together. And then we're going to color those in. Any day you get to color in physics is a good day. I told the kids today in class that I'm going to be an excellent colorer when I get to the nursing home. And I will be the envy of everybody, because most of these jackasses, they stopped coloring when they were in second grade. And I have been coloring my whole life. So I think the chicks will dig it. Actually, I'll still be with my wife, so we'll both be in the nursing home together. So she'll be jealous of all the other ladies at the nursing home that are impressed by my coloring skills. All right, so the green right triangles represent positive motion. So I'll color those in green. See how I stay within the lines? That is a steady hand, my friend. Okay, so now we have to go through and we have to come up with the slope of each one of these. And those, as we know, are the velocities. So I'm going to pause this so I don't bore you to death. And I'll put all my numbers in, then we can figure out slopes. Okay, see what I did here? Turn off this thing. I had the heater on because it was kind of cold. The heater on and the window open. That's not good. It's not very good energy use. All right, so what I did here was I just went ahead and put out the numbers here. This is 30 seconds. This leg is negative 20 meters. This leg is 10 seconds here. This leg is negative, you know what I'm saying? So now what I got to do is figure out what is the slopes of each one of these sections of Slappy's walk/run. Okay, so in the first, so the time intervals here, fill out this table. The time intervals are 0 to 30. 0 to 30 seconds. These are all seconds. If I put it once, then I don't have to keep putting it in there. And then we have from 30 to 40. Then we have from 40 to 60, 60 to 70, 70 to 100. See, I'm getting these all up here. I'm just looking at all my bases here, not my change of position, just my change in time. And then the final one is 100 to 110 seconds. For velocities, now I look at my slope. So the first one, I'll do velocities in blue, I guess. So my first one, I drop 20 and I run 30. So negative, that's negative 0.67 meters per second. 2 siggies is about the best we can hope for here. The next one, I drop 60 and I run 10, so -6. So he really, Slappy went from a slow walk backwards to a very fast run. Remember, when I ran that blazing speed in the hallway, that was only 4 meters a second. So think about Slappy's even faster than that. And then for this next 20 seconds, that's 0 meters per second. Nothing's happening. And then from 60 to 70, he went 80 meters in 10 seconds. Well, that's getting up there. And I don't know what you runners are here at the high school, but that's pretty daggone fast. 8 meters a second. That's like 8 yards a second in football. The 40 yards is what, he got 4.6 speed. So, I mean, we're getting up there, pretty fast speed. I doubt on my best day, I doubt I could run 8 meters a second. That's twice as fast as I ran in the hallway. Okay, then we got from 70 to 100, and that we dropped, we dropped 60 meters, so 60 divided by 30. So that's -2 meters per second. And finally, he went to 20 meters in 10 seconds, so +2 meters per second. Emphasize that those are positive. Okay, now that's about as far as first and third hour got. Second hour got the questions answered. But let's stop right there, and we'll pick it up there tomorrow. Okay, so that's good. I've already talked way too long. So let me stop sharing, and thank you for coming to my TED Talk here. But yeah, so a note to virtual kids, tonight from 9 to 10, we are doing a virtual. So every Monday night from 9 to 10, you'll see it on the calendar. Check that calendar. Every Monday night, we'll do a virtual class from 9 to 10. My neighbor's putting out her trash. Yeah, I got to do that. Okay, so 9 to 10 tonight. Test not till Thursday. I guess I'll see you guys next time. Bye.